All right, as we get into example 5, let's first look over some vocabulary we'll see with complex numbers. With complex numbers, a complex number, let's just call it z, or here if you go from point O to P, we might say it has magnitude, which is the length here, and direction. Now, the modulus would be what looks like the absolute value of the complex number. And remember, A and B are the real and imaginary portions. So real is what A represents, B represents the imaginary. So this doesn't say it over here, but I'll say Z is equal to A plus BI. So what is this? This is the modulus, or it looks like the absolute value. This is the length, the magnitude of z. And so what you do is just like earlier, to find that, you're going to take the square root of a squared plus b squared. That, just like we found the radius earlier today. To find your angle, it's the same thing using inverse tangent. Once again, if you're on the left side of the graph, you're going to have to add pi to your inverse tangent because inverse tangent is restricted. It will not give you answers on the left side, so add a pi to accommodate for that. So let's try some of these. Example 5. It says here, if z is equal to, the complex number is equal to -5 plus 12i, find the modulus of z, or the absolute value of z, or the magnitude of z, whatever you want to call that, and theta. So, and then we'll graph the point of the complex plane. So I'm not labeled here, so I'm just going to go over. I'm going to say this is approximately 5 to the left. So I'm going to say this is -5. This is the real value, -5. And since we're not labeled here, I'm just going to say this is the value, 12. So the point where the intersection, that would be the point here. That would represent let me put this together here. Let me get the right color. Here, that representation here, where I have all of this. Let me do this as dashed lines. This would represent where I have, this would be my A value, my real portion is -5, my imaginary portion is 12. It shows me I didn't place these very well. Okay, let me go ahead and do that. This would be my A portion. A would equal -5. My B would equal 12. And when they say the absolute value of z, that's talking about what's the length of what we normally would call a radius. And so to find that, what we're going to do is the absolute value of z is going to equal the square root of -5 squared plus 12 squared. So mental math here. -5 squared, that is 25. -5 times -5 is a positive 25. And 12 squared is 144. Looks like I forgot a parentheses in there. There we go. Let me just make that easier to read. That is pretty ugly. How about 12 squared? There we go. And when I add those together, 25 plus 144, that is 169. The square root of 169 is 13. So the modulus of z here would equal 13. That's what I just found. Now to find theta, theta in standard position comes from here and goes over. Now notice we're on the left side of the graph, so inverse tangent alone won't work. Your theta is going to equal the inverse tangent of y over x, which the y value, or in this case, is b over a. The y value is b, so b over a, which is y over x. 12 over -5. But since we're on the left side of the graph, we're going to have to add pi to our answer to get that correct. That is not a hand trick. We're going to have to use a calculator. And so I'm going to click functions on my Desmos calculator. I'm going to go to tangent inverse. 12 divided by -5. You should check just to make sure you're in radians, which I am. You can hit the settings right there. Now that would be if the correct answer if we were on the right side of the graph. Because we're on the left side of the graph and tangent inverse is restricted, you need to add pi to that. That's actually going to be our answer value right there. So if it lets me, there we go. Let's snap a picture of that. That's going to be our calculation right there. And so with that, I could approximate and say this is, I'm going to go ahead and round it to the nearest thousandth, so 9.6 and another 6. If you were doing this for AP classroom 1.965 is also acceptable. You could just truncate. So those would be my two values here. So example 5 is just walking us through how you get from the real and the imaginary portion to a length like a radius and a theta, which is preparing us for the polar form. So now with that, example 6.